This is AQA A-Level Chemistry and we're on the Year 13 topic of aqueous chemistry. This is part 4, the final video, that actually focuses a huge amount on observations that you're going to have to remember, colours and complexes, but I'm also going to try to link it back to the theory that we've discussed in the previous 3 videos. So, as always, I'm going to recommend that you pause, have a go at the activities for yourself. I would say try to fill in this table and see just how much of it you can do. I'm going to break it down and we're going to take a look first of all at FeH2O6 plus 2 and then CuH2O6 plus 2, and we've got 2 more that we're going to look at later with an iron 3 and with aluminium 3. In every single case you are going to have to know what you would observe in terms of colour and precipitate or solution in each of the 5 examples that we have. If we had a little bit of OH minus, an excess of OH minus, a little bit of ammonia, an excess of ammonia, or carbonate. And the theory of all of this has been covered in previous videos. We've seen what happens when we add OH minus. We know how it can act as a base, and we have seen one example where adding an excess of OH minus led to a change. We've also seen what can happen with a little bit of ammonia. We know that that's the same as adding a little bit of OH minus, but we've also seen that we can, in certain circumstances, get ligand substitution reactions with ammonia. And we saw what happened when we added carbonate ions, and specifically the difference between when we add it to +2 complexes and +3 complexes. But I'll talk more about those things as we go through. So let's start working down FeH2O6 plus 2. If I add a little bit of OH minus, I will substitute, or I will have 2 OH minuses, each taking a proton, taking us down to H2O4 and OH2. It stops at that point because we no longer have a charge. Now you need to remember the colour. It's green, but also because it's no charge, we know that this is going to be a precipitate. So you would need to be able to remember this colour, that it's a precipitate, what complex is formed, and you would be expected to be able to write an equation for that. Now, if I add a little bit of ammonia, that acts exactly the same way as a base. So we make the same complex. It's the same observation. It's the same equation that you would need to write. The good news, it's exactly the same when we add an excess of OH minus. It doesn't go any further than we are seeing here. And similarly, an excess of ammonia, we don't get any ligand substitution reactions here, so that also stops at FeH2O4 OH2, and we get our green precipitate. A slight change, we did see this in an earlier video. If I take an iron 2 ion complex and I react it with carbonate ions, I make the insoluble metal carbonate, FeCO3. That's a slightly different shade of green, but it's still a green precipitate. Now let's move over to the copper 2 complex, CuH2O6 plus 2. You need to remember, by the way, these initial pale green, pale blue solution. If you add a little bit of OH minus, you will end up making a precipitate. We will get as far as H2O4 OH2. You have got to remember that colour is pale blue. However, you also can simplify this by reminding yourself that a little bit of NH3 will act in exactly the same way. So we still end up with CuH2O4 OH2, the pale blue precipitate. We've also got the good news here that an excess of this, an excess of OH minus, has no impact. It doesn't go any further. So all 3 of these identical. We then have our first anomaly, the first complication. If I add an excess of ammonia, as we saw in the 3rd video, the ammonia can act as a ligand. So it can go as far as 4 of the waters being substituted. NH34, H2O. It's got a +2 charge. Now, you've got to remember the colour. This is actually deep blue, but you should hopefully remember that this is going to be a solution because this is charged, so it can dissolve in water. And then finally, because it's a +2 ion, we end up with our metal carbonate. It's insoluble, and you've got to remember here that it's a blue-green precipitate. So that's the entirety of the first two that you will need to remember and learn. Let's look at the next two. FeH2O6 plus 3. Well, a little bit of OH minus. That will carry on reacting until we hit the precipitate, the brown precipitate here. I have had 3 OH minuses. Each have taken a plus away, an H plus away, and we're left with a brown precipitate. Now, you might also think of iron oxide. Iron oxide, Fe2O3, is rust. That red-brown colour, that's the colour that we are seeing here. So we've got that to help us as well. And if I add a little bit of NH3, as we saw previously, that always stays the same. These two are always identical, whichever complex we're working with. And good news again, if I add an excess of OH minus, it doesn't go any further. It doesn't change. So all of these are the same. Even better news, plus 3 ions do not undergo complex reactions. They don't undergo ligand substitution reactions. So that also stays as FeH2O3OH3. CO3 2-, we do have an additional complication here that's true for plus 3 ions. The CO3 2- ions, we will end up with FeH2O3OH3, the same brown precipitate, but it will also yield CO2, so we will see effervescence. Now, I've noticed there has been an error on here. That should read plus 3. So that's going to be amended going through. And then we're going to take a look at the answers for what will happen with AlH2O6 plus 3. So let's start to take a look. Now, there's an additional bit of information that might help you here. Aluminium is not a transition metal. We know that transition metals form coloured compounds. Because this is not transitional, we know we're going to limit this to either white solids or colourless solutions. So, working through, the aluminium complex will react to get to AlH2O3 OH3. It stops again when it gets to a 0 charge. Because it's a 0 charge, it doesn't dissolve, so it's a precipitate. Because it's not transitional, we know that it's a white precipitate. That is identical for a little bit of ammonia. It's also identical for an excess of ammonia. However, we've got our second real anomaly, because we spoke in an earlier video about aluminium complexes being amphoteric, and we saw that addition of further OH- took us as far as AlH2O2 OH4-. This has now got a charge again, so it's gone to a solution. It's not transitional, so the solution will be colourless. And finally, with the CO3 2-, we have got H2O3 OH3, just as we saw here. We've got CO2 being made, and so we're getting the white precipitate and we're getting effervescence. Just going to finish off with a few little bits of summary information. Looking back at the first two, we can see we've got a pattern here that group 2 complexes will give group 2 metal carbonates. We can see that with iron 2, whether it's a little bit or an excess of OH- or NH3, the reaction is identical. We can also see that that's true for a little bit and an excess of OH- and a little bit of NH3. We can also see that OH- is always identical to a little bit of NH3, whichever complex we're looking at. And I can then highlight the one anomaly that you're going to need to remember beyond those patterns, and that's here. And then if I do the same with the other half, we've actually got similarities right the way down, including in the bottom actually with the brown precipitate. We just got to remember the effervescence down here. We've also got the 3 that are similar here, which is the excess of NH3, sorry, I've just changed that there. The excess of NH3, same as a little bit of NH3, same as a little bit of OH. They all provide the same complex and the same precipitate. And again, similar as we saw with the previous 2, this is common across all 4, that whatever happens with OH- little is the same as happens with NH3 little. We've also got down at the bottom a very similar response when we add carbonate ions to N+3 complexes, we still get the same complex as above, but we also get the effervescence. So the key anomaly on this one is the OH- excess with aluminium 3. There's a lot to think about here, but there's a lot you can do to help coordinate this information in your mind to make it easier and to make it more manageable. But that takes us to the end of this video and the end of this topic. Thank you for listening, and goodbye.